Okay, the last part of this section is about inflation. Inflation in terms of the equivalent number of goods or services that is given amount of money will pay or the power of buy. This periodic increasing in the cost of living is called inflation. And the mathematical law that we can apply to simulate this effect is the exponential function using the base e. Okay, now let's see one example. Suppose that the cup of coffee is the price $1.25 and the inflation rate persists at 2%. Normally the number of the inflation is in between 2 and 4% per year. Find the approximate cost of the coffee in 25 years. So you're using exponential, the formula 1.25 exponential, and r is 0.02 in decimal time 25 years, and the answer is $2.06. Okay, again inflation problem. Okay, the future value is equal the present value exponential r times t. The present value is $1.25 is the price of the cup of coffee. Time multiplication exponential e, and in the exponent we have 0.02 times 25. Let's use a calculator. Exponential. Okay, clear. This is $1.25 times exponential is here, and this key in yellow. Second exponential is 0.02 times 25. Close the parenthesis, and the answer is $2.06. Is $2.06. Okay, let's see another problem. Suppose your salary is $37,000 per year. The question is about what salary would you need in 20 years from now to maintain your purchasing power, and the inflation rate is 2%. Okay, same formula. You put here 37,000 exponential using e constant. In the exponent you put 0.02 in decimal, get 2%, times 20 gets the years. And the answer is 55,197.51. Okay, this is the problem. We have $37,000. The inflation rate is 2%, it is equal to 0.02 in decimal, and the time is 20. Formula is A is equal P exponential RT. P is 37,000 time exponential R is 0.02 time 20. Okay, let's use a calculator. Calculator is, let's do it at the beginning. It's 37,000 time exponential 0.02 times 20. Close the parenthesis. Press enter. It's 50. The answer is 55,197.51. Okay, this is the answer. Perfect. Okay, another easy way, and not necessarily using exponential to evaluate somehow the inflation proportion, is using consumer price index, CPI, which reflect the price of the certain items purchased by a large number of people, like a food, like a house, a car, food, clothing, non-expensive of course, and this is using one proportion. And this is the formula. You have, for example, price in year A divided by price in year B is equal to CPI in the year A divided by CPI in the year A. Okay. Suppose one example to understand the application the CPI. Okay. This example say if your mother paid $3,000 in tuition in 1980 at the same college that you will pay attending and paying $9,300 in 2005, compare the school tuition increase to inflation over the same period of time. This is a formula. The information gets given is, look, we can find in the book the table of the CPI in the year 2005 is this number, 195.3, and CPI in the 1980 is 82.4, and the tuition is given in the year 1980 is 3,000. Now, using cross multiplication, we computed this. X is equal to 7,110 and 44 cents. When you compare, when you divide this and this, you get actually the proportion or the ratio is increasing 0.3, so 30%. Okay. Okay. Let's say one more time. Let's see the problem. But the problem is that you're using the formula. The formula is price in 2005 over price in 1980 is equal CPI in 2005 over CPI in 1980. Okay. The price in 2005, you don't know. The price, this was $3,000. To find the CPI, you go to this table, which is located in one page of the book, in the page 696 here. The CPI in 2005. CPI in 2005 is here. It's 195.3. It's 195.3. Now, in 1980, the CPR is here. It's 82.4. Okay, now cross multiplication. In order to find X value, is this times this times this divided by this. Okay, one more time, use the calculator. $195.3 times 3,000 divided by 82.4. Super. The answer is then 7,110.44. Okay, I don't know. The last analysis was You find, for example, the ratio between the actual value of the inflation and the value that we compute approximately using CPI. Let's see what is the ratio. The ratio is let me store, well, no, not necessary. It's 9300 divided by the last number we have in answer here. It's 1.3. It's approximately, roughly 1.3. That represents one increasing of 30% in the tuition of the college. Okay, and finally one last formula for the estimation for the year to double the price of some items, which is a number of years taken for the general level of the price to double for the given annual rate of the inflation. It's easy. It's basically the number of years is 70 divided by annual inflation rate. Suppose the annual inflation rate is 2.1, it's 7 divided by 2.1, it's 33.33, which is approximately 34 years. Okay, calculator is 70 division the rate of inflation is 2.1. The answer is 33.333, approximately 34 years. 34 years. So in 34 years, the price, using this rate of inflation, the price of some item is duplicate.